Okay, this function is a polynomial, so we're used to polynomials. We expect some type of curving or whatever. More importantly, what we know about polynomials is that they don't have any asymptotes or anything like that. So we don't have to worry about that with this one. Okay, if I wanted to, I could go ahead and find my x and y intercepts. Okay, I find my x-intercept by letting y equal 0. So we got 0 equals minus 2x to the fourth plus 3x squared. Okay, if I factor, I can factor out what? Okay, x squared maybe. Okay, I'm going to factor out negative x squared. That leaves me with 2x squared minus 3. Is that right? Okay, so 2x squared minus 3. So if I set each of these equal to 0, I get x equals 0 from here. And then 2x squared minus 3 equals 0. 2x squared equals 3. X squared equals 3 halves, or x equals plus or minus whatever the square root of 3 halves is. Okay, so approximately plus or minus 1.22. Thank you. Okay, so those are a couple of points that we're going to have on our graph. We already know we're going to have a point at 0, 0, okay, because we said y was equal to 0, and we saw for x it was also 0. And then we're going to have 2 additional points at plus minus 1.22, comma 0. Okay, and of course we can find the y-intercept by letting x equal 0. And if we do that, I think you can see that y comes out to 0, so we already have that point. Okay, so these are 2 points, and I'll start over here. We're going to need a lot of paper. Okay. Okay, this is just rough, but let's say 1.22, okay, minus 1.22 and 0. These are 3 places where we know the function is equal to 0. Okay, so we found the intercepts already. All right, now I want to look at any derivatives to figure out where the function might be increasing. Okay, so we got y double prime, or y prime rather, is equal to minus 8x plus 6x, or minus 8x cubed plus 6x. Okay, and so of course I'm going to set that equal to 0. All right, I can factor out x, or maybe even 2x if that's what I want to do. Okay, I'll factor out negative 2x. And that's going to leave me with 4x squared minus 3. Is that right? Okay. And so again, I set these equal to 0. Well, I took out a negative 2x. So it depends on whether or not you take out the negative or leave it. Okay. Okay. All right. So we get x equals 0 from here, and then 4x squared minus 3 equals 0. 4x squared equals 3. X squared equals 3/4, or x equals what? Okay. All right, plus minus, we'll say root 3 over 2, which is how much? Okay, so plus minus 0.87. All right. So I need to know where it's increasing and decreasing. So I'm going to set up my first derivative test from minus 0.87 to 0 to 0.87. And of course, we've got minus infinity on this end and plus infinity on the other end. Everybody okay? All right, so we pick test points. I might pick -1. So I got to pick 0.5, or rather negative 0.5, then positive 0.5, and then 1. And if I'm interested in where this thing is increasing or decreasing, I'm going to plug it back in where? Into the first derivative, okay? So we don't have to have the exact value. We just need to know what the sign is. So I've got -2 times -1. And if I put -1 in there, I get 4 minus 3. That's positive. So -2, -1 sounds like this is positive. Is that right? Yes or no? Okay. Positive. Yes. Okay, I'm going to take that as yes. All right. If we do minus 0.5, -2 times -0.5, okay, that's going to be positive. 4 times 0.5 squared, that gives me 1 minus 3, so this is negative. Okay. All right, -2 times 0.5 is going to be negative, and then when we put it over here, we get negative, so this is positive, and then if we put in 1, okay, negative. Okay, so now we have some idea about where the function is increasing and decreasing. Okay, before I do anything with that, I need to know, it'd be helpful to know what f of, I'm going to use the exact value, √3/2 is. So somebody find that for me on the calculator. Also f of 0, I think we already know that that is 0. And then f of positive, this one is supposed to be negative, and this one is positive. Because the square root of 4 is 2. We were able to reduce the denominator. All right? Because I'm going to actually plot these points on my graph. And then we're going to, before we get to -√3/2, I need to be increasing to that point. When I get at that point, what should happen? It should change because at -√3/2, we had what? It's a critical value, and so the slope at that point is what? 0, okay? Well, we don't know that yet. We got to look at the second derivative to talk about concavity. So it could be increasing like this. If it is, then it's concave down. Or it could be increasing like that. Both of those are increasing, but this one is concave down, this one is concave up. So in order to figure it out, I got to look at the second derivative. Okay? Everybody okay with that? All right, so what do we get for f of -√3/2? Okay, 1.125. Okay. All right, and then we got 0 here, and I'm going to guess we got 1.125 for this one as well? Okay. All right, so let's go ahead and put that information on our graph. Okay, -√3/2, which we said was about minus 0.87. Okay. So minus 0.87, and if this is 1, so maybe we got something about right. Let me get my red pen. Something about right here. Okay. Then we're going to go to positive 0.87 and 1.25. Okay. And we got a pretty good idea already about maybe what this graph should be looking like. Okay, it's got to go through this point. It can't go through 0 before here. Okay, and then after that, we're going to have to go here, then down here, here, and here. Okay, so the question is, does it look like this? What does it look like? Or does it look more like that? Okay, we're going to find out. Okay, questions about what we have so far? Yes.
So what are those 2 points we were just talking about?
They are points where the derivative was equal to 0. Okay? In fact, the derivative was equal to 0 here, here, and also here. So we can expect to change from increasing to decreasing or vice versa based on what we saw down here at those points.
Alright. Is it not, can we find like a relative max in that?
Yeah, we could say that. Okay? We were increasing, then we are decreasing. So yes, at negative 0.87, we have a relative max. Okay? And then at 0, we've got a relative min, and at positive 0.87, we've got another relative max. So the only thing I need to know now is just about that concavity. Is it concave up or concave down? So I'm going to look at my second derivative. And we get minus 24x squared plus 6 equals 0. Okay, or 6 equals 24x squared. 6 divided by 24 is 1/4. So x equals what? Plus minus 1/2. Okay. All right. So at x equals plus and minus 1/2, well, we need to set it up to see what's going to happen. Minus 1/2, plus 1/2. Okay, my test points are going to be -1, 0, and 1. And we're looking at the second derivative to talk about concavity. All right, so if I put in -1, looks like I'm going to get, I got negative. Okay. Okay. If I put in 0, we get positive. And if I put in 1, I get negative. Okay. And then I would plot f of -1/2 and f of 1/2. Okay, go back to the original function and figure out what those values are. Okay, what'd you get? Then we're going to put it all together in just a second. Okay, our original function was minus 2x to the 4th. Okay. Okay, 0.625. Okay, I heard that from 2 people, so that's great. All right. All right, so if I plot these points, we've got -1/2. That's about in here. 0.625, so that's about here. And then plus 1/2, 0.625. Okay, and then if we go back and look, this says from minus infinity to -1/2, this thing should be what? Concave down. Okay, and we already kind of got our increasing, decreasing worked out, so I'm going to do it like this. Trying to hit all the points. Okay, concave down. At that point, we have a point of inflection, and so now it's going to be concave up. Okay, it's concave up from minus 1/2 to plus 1/2. Okay, those are the x values. Then it starts to be concave down again. Okay, and so it looks something like that. Okay, a rough sketch, but there we go. Questions about that?
At the 0, how did you know
That it was flattened? Because one of my critical values was 0. We had 3 critical values, the minus 0.87, 0, and 0.87. Okay. All right, other questions? Okay, very good. So if we wanted to verify what this looks like, we could get I suppose, a decent picture of it. Minus 2x to the 4th. Was it plus 3x squared?
Yes, ma'am.
Okay. All right, so there's what we tried to draw. Okay, questions about that? We were able to get that without having to use our graphing calculator. Okay. Shall we try it again? Or you got it? Okay, I got one person who says we got it. Yes, no, maybe. Let's try one more just to be safe. All right, we still got some time. All righty. Let's look at you want to do C? Y'all like C? Okay, let's do C. All right, we got f of x equals minus x squared minus 4x minus 7 all over x plus 3. I'll let you work on it a little bit. Now this function is different, and one of the first things we should probably consider is what? It's going to have asymptotes. Very good. Okay, the asymptote's going to be where? At x equals negative 3. So I would draw that in my graph first. I don't know why I can't capture it. Okay, minus x squared minus 4x minus 7. All right, that's worth at least a point. All right, you got the asymptote there. All right, and then we can go on and also still try to find those y-intercepts and x-intercepts. So for my y-intercept, okay, if I put 0 in for x, I'm going to get negative 7/3. So, all right, and then we can try to solve for y equals 0. But looking at this, if I say 0 equals negative x squared minus 4x minus 7, can we factor that? No, doesn't look like it. And We could try the quadratic formula to see if that works. Okay, x equals minus b, so that would be 4, plus or minus the square root of b squared, so that'd be 16 minus 4 times -1 times -7 all over 2 times -1. Okay, well that's going to give me 16 minus -28, which would give me an imaginary number, so I don't have to go any farther with this. Okay, so here's our only intercept, 0, -7/3. Okay, all right, so let's plot that. Okay, 7/3 is going to be a little more than 2, so right here. Oh, was it negative? Okay. Okay, -2 1/3. All right. So now I'm ready to take my derivative. Yes.
Where's the negative 7/3 from?
I plugged in 0 for x. So, yeah, so we get -7/3. Okay. All right, so I'm going to try to take my derivative. We got low. Derivative of high is minus 2x minus 4. Okay, minus high. Derivative of low is 1. Okay, all over low squared. All right. And so we got to clean this up top. We get minus 2x squared minus 4x minus 6x, right? Minus 12, okay? Plus x squared plus 4x plus 7 all over x plus 3 squared. Okay? So minus 2x squared plus x squared gives me negative x squared. Okay, looks like I got some 4x's canceling out, so we get what? Minus 6x, and minus 12 plus 7 is what? -5, right? Okay, all over x plus 3 squared. Okay, so our critical values, okay, we would normally set our numerator and denominator equal to 0, okay, but we learned, I think that was last time, that this is not going to be or give us a critical value in this case. Why not? We had this discussion. Why won't we get a critical value of x equals -3? Right. At x equals -3 is not a part of the original function. Okay? We talked about that. Remember you asked me about that problem from homework? Okay? And we said, they said the reason was because this was not in our original domain. However, we still need to use it to set up the intervals, okay? Because the function is going to be discontinuous right here, then it could change in lots of different ways, so we need to kind of make that a stopping point as we look at it, okay? So I'm going to look at negative x squared minus 6x minus 5 equals 0, or minus x squared plus 6x plus 5 equals 0. We can factor this. Can we factor that? I hope we can. No. Yes, okay. X plus 5 and x plus 1. Okay, very good. All right, so then our critical values would be x equals -5, x equals -1, and then we're also going to look at x equals -3. Okay? Yep. Okay, so let's set up our intervals. -5, -3, -1. Okay, yes, that makes sense. All right, then we get -6, -4, -2, and 0. Those are going to be my test points. And so we talk about f prime. Okay. All right, so if I plug back into f prime, we notice that our denominator is always going to be what? Positive, very good, because it's squared, right? Okay, and we don't have any coefficients out front. So that's always going to be positive. So really, we just need to plug in to this thing. We got a negative and then whatever these two factors come out to be. So if I put in -6, -6 plus 5 is negative, -6 plus 1 is negative. 3 negatives gives us what? Negative. Okay, then we got negative 4 plus 5 is positive. -4 plus 1 is negative, so we get 2 negatives. That's positive. Okay, then we got -2 plus 5 is what? Positive, right? And then -2 plus 1 is negative, so this is going to give us positive. Then we put in 0, so we get 5, 1, and then a negative, so negative. All right, so it looks like the function is going to be decreasing and then increasing. Okay, let's go ahead and figure out what f of -5 is, f of -3, and f of -1. Okay, what'd you get? Anybody? Negative x squared. Okay. All right. Okay, 6 for -5. -1 gives you -2. And then f of -3 is what? Oh, that's right. That's where we have our asymptote. Okay, so very good. Okay, so then I would plot these points. We got -5, 6, and -1, -2. Okay, so 1, 2, 3, 4, 5. That's -5, 6, 1, 2. 1, 2, 3, 4, 5, 6. So -5, 6. Okay, and then -1, -2. Okay, so this is good. All right. So even at this, it gives me some idea already, except we said we didn't have any x-intercept. So it gives me some idea already about what the graph is going to do, right? I've got a few points, and did we plot our minus 7/3? We said when x was equal to 0, it's right here? Okay. All right, so let's look at then our second derivative. And before we do that, let's talk about from minus infinity to minus 5, we expect to be increasing. Okay, so somehow we need to be increasing and then hugging this point. So when we think about that, how could that happen? Okay, it looks like it's going to have to be concave up. You know, eventually we're going to be hugging that asymptote, right? If I'm going to go through this point and end up hugging this asymptote, that's probably what this is going to look like. Okay, I'm just kind of thinking ahead. All right, and then from minus 5 to minus 3, I think we already said that, or did we do that? Minus 5 to minus 3, it should be increasing. Okay, we already did that, right? And then on the other side, we've got minus 3 to 1 also increasing. So here's minus 3, here's 1. How's that going to be increasing? I'm not sure. I can't quite see that one. All right, but yeah, but it's got to hit both of these points, except at minus 1 it starts to decrease. So that might make sense. We kind of see that it's decreasing right here. Okay. All right, so let's move on. We got to take our second derivative. Okay, I'm going to try to take it from right here. Is this the right one? Yeah. Okay, my second derivative is f double prime of x equals, I'm taking it from right here, so low derivative of high is going to be minus 2x minus 6, okay, minus high, so high was what? Negative x squared minus 6x minus 5, okay, derivative of low is going to be 2 times x plus 3 to the first times 1, okay, all over low squared. So that's x plus 3 to the fourth. Okay. So we get any values from here. Okay, how am I going to reduce this? Okay, we can factor out x plus 3. Okay, we're left with x plus 3 times negative 2x minus 6. Okay, minus 2 times negative x squared minus 6x minus 5. Okay, all over x plus 3 to the fourth. Okay, we can go a little farther to simplify this.
The x plus 3 be, the second one should be the third.
Which one?
The x plus 3.
Here or here?
Right there.
This one, should it be to the third?
How do you do that?
Well, it was squared, so we factored 1 off.
Okay.
That left us with 1. Okay? Let's see if I can move this out of the way. Okay, anyway, it's over there. Okay, so when we continue this, we get x plus 3 We're just going to have to multiply it all out. So we get what? Minus 2x squared. Outer is minus 6x. Inner is minus 6x. And the last is minus 18. Then we're going to have plus 2x squared plus 12x plus 10. Okay, all over x plus 3 to the fourth. Okay, and so we get x plus 3. Okay, we got minus 2x squared plus 2x squared. And so we got minus 6x, and plus 12x. Those cancel out. So it looks like I just have minus 8. Do you agree? Okay, minus 8 over x plus 3 to the fourth. Yay. And of course, those are going to cancel out. So we get negative 8 over x plus 3 cubed. Okay, that's our second derivative. And it only has an important point at what? At negative 3, right? Is that what you said? Okay, only at negative 3. So I just need to look on both sides of negative 3 to figure out, what the concavity is. All right, so I'm going to pick negative 5 and 0. Okay, if I pick negative 5 plus 3 is negative. If I cube a negative, it's still negative. But with this negative up top, that's going to be what? Positive. Okay, when I plug in 0, we get 3 on the bottom, but it's still negative on the top, so we get negative. So that means from minus infinity to minus 3, this thing is going to be concave up. And then from minus 3 to infinity, it should be concave down. All right? So let's see if we can make sense of that. It's concave up all the way over here. And we talked about where it was increasing. Also, we've got a slope of 0 at negative 5, negative 3, and negative 1. So let's kind of, and we never did plot those points, or did we? Okay, f of negative 5 is negative 6. Let me, yeah, something, that was just a rough thing, but what I do know is that at that point, I need to have a slope like this, right? Okay, because it was a critical value. And at negative 1, this was our other one. And what was the other value? I feel like one of them. And negative 3 was just our asymptote. Okay. So concave up, but decreasing. Concave up, but decreasing. So if it's concave up and decreasing, maybe that's going to look a little more like this. Concave up and decreasing. Okay. This is decreasing, right? Okay. And it's oh, I'm sorry.
Decreasing
It's
going the other way, wouldn't it? Coming down.
it is decreasing. Okay. But that's the I mean we could look at it now, but the whole point of it is
I'm looking at the
for us to be
calculator.
able to graph it.
You come down and then you go to the left, like a backwards L.
Maybe it's like a cube.
A cubic function?
Yeah.
So like this. But now until we get to -3, the whole thing needs to be what? Concave up. So it can't be like that.
That would be kind
So
of.
go back up. I see. So like
Then go back up.
this, like this.
Because negative into -3 is
Yeah, that kind of works.
Okay. All right. That works. Okay. All right. So we go all the way back up. Okay. And then over here, it's going to be concave down. All right. So we don't have any zeros. So it looks like this thing might look like what? We got a cross right here. This is a max. So something like that. And then over here, is it like that? Okay. Well, there you go. All right. So that's a rough sketch of it. All right. The point is to, be able to use the information to come up with the graph. Now, if you get the derivative wrong, if you get the wrong critical values, okay, any of those things will just go mess the whole problem up. So I'm going to work on trying to maybe give you the right information.